Alright, so we will start from problem I. Okay, so here we notice that it has a log on both sides. Yes, we notice that we have log on both sides, basically ln, log with a base e. So for me to use this property, log of u equals log of v, they both have to be, there has to be only one log term on each side with the same base. So the problem now here is, yes, they do all have the same bases, but there are two terms here. So can we, as a step number one, can we combine that into one term? So when I combine them, what does that become? Perfect, awesome, good answer. Did everybody get that? Because it basically becomes ln of 11 times 2. Because you multiply. Remember, addition converts to multiplying when you condense it. And now after this, it's easy actually. I think when there's log on both sides, it's a fairly easy situation because all you have to do is equate these two and solve for x. Yeah, are we doing okay? I checked, for anyone who's still unsure about the checking part, I took x equals to 9. 3 times 9 is 27. 27 minus 5 is 22, so which is positive, so it works. Alright, let's look at, can you all do J without my help? I will show the work I'll follow you guys in a minute. I'll give you guys time to start. Okay, can we all hit pause and just, if you're working, just make sure you got the first two steps, okay? And then continue working. You will again have a quadratic, but a slightly easier one. Factors of 100 that add up to 15. If I look at my statement at the top, there's just log of x, so I know any negative value will not work. I don't even have to do any calculation. There's the input for log is x, and the input for log is x plus 15. It doesn't matter, even if one of them doesn't work, it doesn't work. So I know any negative will not work, so x equals to negative 20 will not work. I don't have to do any calculation, and x equals to 5, it's positive 5, log of positive y works. 5 plus 15 is 20 works, so 5 works. Okay, let's go ahead and do, we'll just do as many as we can. Let's do k L, M, and N. Well, let's do all four. Let's do one at a time. Let's do K first. So, okay, let's just discuss K before I let you guys work. So, what do you notice? You have logs on both sides. Everybody can notice that? You have logs on both sides, but on both sides there are multiple terms of log. So, for me to be able to equate the inputs of both the sides, it has to be only one log term. So, you will condense both the sides first, and then equate the input from the left side to the right side. Then it becomes easy. Okay, so this is actually just a linear equation because it's only x to the first power. There's no x times x because both of them are multiplied. You distribute a constant. So you actually have a linear equation, solve a linear equation. And I'm just going to write the final answer. Please tell me if you don't see this. I will be glad to do the work. But distribute the 2, distribute the 4, combine the x terms and see if you get x equals to 5. And x equals to 5 works because you do the check and it will work. 5 plus 2 and 3 times 5 minus 1 is all positive. Does anybody need more time for K? Okay, alright. Then let's look at L. What do you notice about L that's a little different? Do you have log on both sides? No, you have log only on one side. So we will use the method to basically convert into an exponential. But what's standing in the way? There's 7. Perfect. Someone said that. That's absolutely the right answer. You want the move. So always remember when you're trying to solve for an x, the term that contains the x should be by itself, or the two terms that contains the x should be by itself. So you want to move all the constant to the other side and just keep the term that contains the x on one side. So on this side it will just be log. I don't know why they've written base 10 because log base 10 is just log. I'm not even going to write the base 10 of x equals to. Move the 7 over to the other side, negative 7, it becomes negative 3. Okay, now it's easy. Now can we all rewrite this in the exponential form and solve for x? Remember the base is 10. Okay, so you'll write 10 to the power of negative 3. That's what you do. So I do have my answer for x straight away, except you don't want to leave your answer in the negative exponent. So x equals to 1 over 10 cubed, right? Isn't that what happens? Okay, please tell me if you, okay, let me number the steps. If you're not sure how I went from 1 to 2 or 2 to 3. Or x equals, 10 cubed is nothing but 1000, and it works because it's a positive value. Alright, we'll go on to M. M is sort of similar to L. Any questions on L? Can I go to M? Okay. So M is sort of similar to L in the sense that the term that contains the x has a constant hanging around, so you want to move the constant to the other side and then try to convert it into exponent. So step number 1 will be 2 ln of x equals 8, because plus 3 on that side. But you have to do one more thing before you convert. Yes.
Do you make the 2 the x?
Yeah, I was just going to get to that. So before I can't really rewrite this as an exponent if there's a coefficient. So you move the coefficient as an exponent. So you always have to do that. If you see a coefficient, you always want to move it if you're converting. Now you can go ahead and rewrite it in the exponential form. So remember, e to the 8th power is a constant again. You can also do one more thing. I think now, in hindsight, I think that's an easier one. I'm just going to do that right now. Instead of doing this and taking the square root of E8, this is what we're going to do. For me to get ln of x by itself, can I also not divide by 2 on both sides? I can. What's preventing me from doing that? You will get the same answer. So I do ln of x equals to 4 because I divide by 2 on both sides. 2 is the coefficient, so I can also do this. And I think this may be an easier method. Then I do e to the power of 4 equals to x, and that's my answer. And which is what I'll get here too. I take square root on both sides. Square root of e to the 8th power is e4 plus or minus, but the minus will go away. So you will get the same answer. But I do think this is an easier way to do it. Okay, let's do n. We're pretty much kind of coming to the end of the class. We'll have some time if you guys want to work on the review, but we'll do we'll do n, and we'll do one more in the next page, and then we'll wrap it up. So, everybody okay with m? Before I go to n? Okay, let's look at n. N is straightforward. I think it's pretty straightforward even to begin. I don't think I have to do anything except there's on log only on one side, so I can just straight away convert this to exponent. So let's do it. My base is 2, so 2 to the power of 4. Yeah, so why don't you guys do it? N is straightforward. The only thing in n is a check, so I want you to kind of keep your eye open for the check in the end. Did we get so far? Do you think negative 11 works? Yes, awesome, good answer. I do have I think one common mistake students do is they do 5 minus 11, which is a negative number, right? 5 minus 11 is a negative number, but it's actually not 5 minus 11, it's 5 minus, see if you look at the input for this, right? We are substituting it here. So it's 5 minus, what is x? The value of x is negative 11. So we are actually looking at 5 plus 11, which is 16, and which is a positive value. Therefore, it works. Just always be a little careful when you see a negative substitution. Remember, then it changes the symbol. It's negative times negative is positive, and therefore it is positive. Yeah? Be good? All right. Next page. I would like us to do R a little different. I'm just going to talk about it and just making sure we're on the right track to start it, and then I'll let you guys figure it out. So this is the kind where you have ln on both sides, which means I can, but this ln on the right hand side has multiple terms. That means I can condense. So this needs to be condensed. That's the first step you'll do. And once you condense, also the 2 needs to go. As an exponent, also the 2 needs to go. So then you'll be in a situation where you say ln of something equals ln of something. That means you'll equate the input. You may have a linear, you may have a quadratic, and solve for it. Okay, I'll let you guys work on this, at least till we arrive at that linear or quadratic, and then we'll talk about how to solve it. I'm going to go ahead and show just the first step, just to make sure your condensing is okay and just that first step. And then I'll slowly show the other steps. Yes, everybody should have, you can now equate the inputs. That's what I'm doing as step number 2. And then your next step should be, you should multiply out the binomials, 2 binomials, and then combine that with x squared and write the standard quadratic form. That should be your next step. I'm going to leave this up so that this is the quadratic you should finally get when you write it in the standard form. But please do the work. Obviously this one does not have the work, so if you didn't get x squared minus 5x minus c, please ask me so we can do the work together. But I want you to try. All you're doing is multiplying these two and combining it with x squared. Yes.
I have 2x squared minus 5x minus 3.
And then on the other side you have x squared. So you move the x squared to this side. No, you're good. You're good. So what you're telling me is what's on the right hand side. So you have what you've just read out is x minus 3 times 2x plus 1, correct? But then you also have the x squared on this side. Remember, you always have to write it in the standard form, meaning you will move the x square to this side once you multiply it out. So look at this side. This side says 0. How did I get my 0? Because I moved the x square over to this side. Make sense or no? Not yet. Okay, let me write it up for you.
Just solve.
Yeah. So what did you get? You got 2x square. Keep reading.
I have what you have, minus 5x minus 3
This is what you got, and that's correct.
equals x squared.
Equal x square. But this is not standard form. This is not standard form because you don't have 0 on this side. Standard form of a quadratic equation is, okay, let me go ahead and write down the standard form. It's ax square plus bx plus c equals to 0. This is the standard form. It has to be in this form for you to be able to factor it or solve it or anything. Whereas here we notice it's 2x square minus 5x minus c, and there's still an x square on this side. So you move this over to this side. I'll be with you in a minute. So you do minus x square from both sides. So this becomes x square minus 5x minus 3, x square minus x square equals 0. Does that make sense? So you have this. So this is more standard form, which is what we had done in the others.
Then you just divided out the in.
Divided out the.
Log.
So you're talking about step 1 to 2. No, which step
Yeah,
on?
step 1 to 2.
Step 1 to 2, all I did was, more than dividing it out, I'm using the property where ln of A equals ln of B. That means A and B have to be equal to each other.
Okay.
Yeah? Okay. Because ln is a function, so you really can't divide a function. Okay. And Serena.
Is that it?
Yeah. So I wanted to talk about this. Is everybody good till this step 3? Everybody got that as a quadratic? Okay, so now my question to you is, can I factor this? No. Okay, good answer. So what do you think you'll do? You still have to solve it. Just because you cannot factor doesn't mean you shouldn't solve it. Quadratic formula, excellent. Or what else have we learned? Completing the square. Perfect. We can do either one. Let's take a few minutes to finish it up. And yeah. No, yeah.
So if you minus x squared from both sides, then why is it still x squared minus?
Oh, because it's 2. So you do x square from both sides. Remember, you write like terms below like terms. So you understood why this became 0, right? But here it's 2x square minus x square.
Oh, so you still have 1 x squared.
You still have 1x square. Correct. Okay, so you can use quadratic formula or completing the square. The work that I've shown on the key is completing the square, because that's what we should actually at this stage really get comfortable with. So completing the square is where you'll move the 3 to the other side, take 5. But I'm not going to. If you want to use quadratic formula, that's fine, as long as you get the answer that I show you. And then take the b, divide by 2, square it, add to both the sides. That whole process. You'll do the whole process. So I'm showing you the work for completing the square, but if you're not doing completing the square, like I said, I am okay with it. But we do, especially if you're moving on to calculus, we have to know how to complete the square. Because that's an important, what shall I say, skill to have. It's a quicker way to solve equations, and we should know how to do it, period, yeah. I'm just going to go ahead and show you the final answer. So whether you use quadratic formula or completing the square, this is what you should have got.
Is that 37?
37, yes, this is 37, because by 4, right? So this becomes 12 by 4, so 12 plus 25 is 37, yeah. All right, you guys can finish it up. Yeah.
Why did you move the 3 to the other side?
Okay, this is the completing the square method, where you move the constant to the other side and then take the b and divide by 2 and square it. So this is the, that method. Where that's the first thing you do in completing the square. You move the constant over to the other side.
Why did you divide it by 4?
Okay, now, so you're not dividing it by 4, so quickly, just let me give you a quick rundown about completing the square. So completing the square is x square minus 5x. First step you do is to move the constant over to the other side. So step number 1 for completing the square. Step number 2, you take the b, which is negative 5, divide by 2 and square it, and that becomes 25 by 4. So do you remember this? This is sort of coming back, and then you add 25 by 4 to the left hand side and the right hand side, and yeah, so and then you write it as a perfect square binomial, and then take square root on both sides, and yeah. So you will have your completing the square as one of the questions in your final exam activity. Did I talk about the final exam activity or no? Okay, I'll give you guys 30 seconds, finish this up, and then I'll talk about it. Oh yeah, sure. Sorry, I'm going to stop recording.